Have you ever needed to use MutationObserver? Would you like to know how it's able to observe and notify DOM mutations, and why is it so efficient? This is Deep Frontend Lore. We're going to dive into how browsers implement the mutation system in their internal layers. But before that, let's briefly review what MutationObserver is used for and look at a simple example. MutationObserver is a DOM interface that lets you execute a callback when a mutation occurs in the document's tree. You can choose which node to observe, whether you want to include all of its descendants, and which types of mutation should trigger notifications, structural changes, attribute changes, or modifications to text nodes. Imagine you're developing a browser extension for a chat website that translates incoming messages in real time. How do you make sure you translate a message exactly at the moment it's inserted into the DOM? You could use a set interval to inspect the chat container, but that doesn't sound efficient, does it? Instead, you can use MutationObserver to watch the chat container and execute your translation logic at the precise moment the DOM engine inserts a new node. The implementation would look like this. This code initializes a MutationObserver with a callback that receives an array of mutation record. We'll talk more about mutation record later. For now, it's enough to know that each one contains information about a specific DOM mutation. Then, you call observe, which receives the node to observe and a configuration object. There you can specify which types of mutation you're interested in, whether you want to observe mutations throughout the entire subtree, whether you want to filter only specific attributes, and whether you need the previous value. When a DOM mutation occurs that matches the configured options, the callback will be executed. Perfect, that's very convenient. But what if I told you that in reality, the observe method is not actively observing anything at all? How does this entire mechanism work behind the scenes? Understanding this helps you make better decisions when using MutationObserver. To understand what happens internally, we need to forget about JavaScript for a moment and think in terms of the DOM engine layer. And although each browser implements this process in a slightly different way, they all follow the DOM standard. Every node has an internal list defined by the standard as the registered observers list, which is empty by default. When observe is called on a node, the DOM engine adds an observer registration to that list. This registration contains a reference to the MutationObserver object, the one holding the callback we defined, and the options we pass to observe. And that's it. Let's see what happens when a mutation occurs in the DOM. Returning to the chat example, when a new message arrives, a new element is appended to the chat box. At this point, the DOM engine handles inserting the node internally. Just to clarify, each engine handles this differently. For example, Gecko, the Firefox DOM engine, performs this inside a function called insertChildat. During this process, after performing the logic required to insert the node, the standard mandates that the algorithm queue a tree mutation record must be executed, corresponding to child list mutations, cases where nodes are added or removed. In that process, a list called nodes is created. It contains the mutated node, the target, and all of its ancestor nodes. One of those nodes is the chat box element that we are observing with MutationObserver. A second structure is also created, an empty map called interested observers. For each node in the list, its registered observers list is examined. As we mentioned earlier, this list is empty by default. But when we called observe and passed the chatbox node as the argument, the DOM engine stored a registration there. For that reason, when the algorithm reaches the chatbox node, it will find that there is an observer registered. If the nature of the mutation matches the configuration we defined in the observe options, that observer will be placed inside interested observers. Once all nodes in the nodes list have been processed, the algorithm iterates through interested observers, and for each observer in that map, a new mutation record is created with the mutation information and appended to that observer's record queue. What happens to that observer now? At this point, the observer already has a mutation record in its record queue, but the callback is still not executed. The HTML standard specifies that all observers that have received records must be added to a global set called pending mutation observers. This set is owned by the window agent, the entity that manages the document's microtasks. If no microtask has yet been queued to deliver mutations, the browser sets a flag we'll call MutationObserver microtask queued, and schedules a microtask to run the algorithm notify mutation observers. This part is crucial. MutationObserver callbacks are never executed during the mutation itself. They are always executed later, at the next microtask checkpoint, alongside resolved promises and other microtasks in the document. When that microtask finally runs, the browser sets the MutationObserver microtask queued flag to false, takes all observers from the pending MutationObserver set, clones their record queues before clearing them, and executes the callback, passing the array of mutation record objects as the first argument. Did you know this process in depth? There's still much more to learn. For example, in this investigation, we did not mention the disconnect method or its implications within the DO engine layer. We might cover that in another investigation. Or maybe you'll be the one contributing that knowledge in the comments. Thank you very much for joining us. This was Deep Frontend Lore. Our purpose is to understand the mechanisms that make the front end possible. We stay rigorously technical, but that doesn't make it any less interesting or enjoyable. You're welcome here even if you just came to have a good time. If you want to truly master front end and understand how and why things work, you'll need to go beyond conventional articles and tutorials. Deep Frontend Lore will provide you with starting points for your own investigations. Come back and tell us what you've discovered.